Hi everyone, welcome to another video on Python code Nemesis. In the previous video, we learned about dependency management with dependency injection, design patterns in Python. We learned about containers and providers and how dependency injection can help us manage dependencies efficiently. In this video, we will walk through a code example for dependency management with a Flask application. So, as you can see, in the previous video, we did go through this class and a few containers and how we can use a container to initialize and execute all the functions in this database class. Here, we will create a function using an app container and run it, and also connect to this database using providers. So this is a very simple code for a Flask application that demonstrates how dependencies can be managed using the Flask framework and the dependency injector library. So first, from Flask, we import Flask in JSONify. JSONify is for the result, for the root. Dependency injector, we import containers and providers. We know for what these both are used for at this point. Providers are to use that dependency, containers are to containerize those dependencies. This is our database class with 4 functions. The initialization function with the database name and connected, a connect function to set connected to true, a disconnect function to set connected to false, an execute query that just returns a string saying that it executed the query on the database. In case you actually wanted to execute this on a real database, you could use Postgres or MySQL to do that. Now we have an app config, which inherits from containers.declarative container, which has this field, database name, equal to providers.configuration database name. So it's supposed to provide this configuration when we call this. So let's see where we are calling this. App config, right here. So we are calling this app config in the app container. This app container also inherits from containers.declarative container. It has this field config, which is providers.configuration, and database, which is providers.singleton, which is a singleton provider. Database, that database class, this will give you a singleton object of this database class with the database name, which should come from this application config.database name. Right. Now we will initialize the app. Again, a singleton provider, Flask, and name. App.config.from object. So what is this from object? This will get the configuration of the app from this object, which is providers.configuration. Let's continue. So this is again a decorator which defines this function as a singleton provider. So there is a parameter database.connect, return database. So this will just set the connection equal to true. This is the home index root. So it has this function get database connection equal to get database connection. So you see this parameter calls this function. So query result equal to get database connection dot execute query. So what does get database connection do? It does a database dot connect and returns database. What is database? Database is a singleton provider of the class database with the DB name as appconfig.database name. Right. So this query result does a get database connection, which gets the singleton provider dot execute query. So it will go to this function, and it will return this string query executed on database self.db name. Question is, where did it execute the DB name? So in app config, we have providers.configuration database name. So what did we do in the previous one? We did the same thing. In database container, we passed in the database name. Okay, so you can again put in your different configurations in here. Yep, that works. So in the main function, you do an app equal to app container dot app, and then you do an app dot run. So when you do an app container dot app, what is the app container? This is the app container. What's app? App equal to providers as singleton Flask dot name. Great. So it initializes this Flask app, and then app dot config dot from object config. So all the application config comes from this. Here is where you can pass in the DB name, because again, this can come from that. And then you run the app, which should give us, which should be running on localhost 5000. And if you hit the index with this, or if you just do a curl request, it will return this query result. Going through the code again, in this example, we first define a database class which represents a database connection object that has a dependency on a database name. We then define two dependency injection containers, app config and app container. App config is a configuration container that provides the database name configuration value, which is used to initialize the database class. App container is the main dependency injection container that creates a Flask application object and the database object. We define a get database connection provider function that calls the connect method on the database object and returns it. We also define an index route that uses the get database connection function to execute a query on the database and returns the results as a JSON response. When the application is run, the app container.app method creates and returns the Flask application object, which is then run using the run method. This example demonstrates how dependencies can be managed using the dependency injector Python library and Flask framework, and how the dependency injection pattern can be used to decouple the creation of dependencies from the objects that use them. Using a container in dependency injector. Here's a simplified example to use a container in the dependency injector library in Python to configure dependencies and their life cycles. So again, this is a bit out of order, but in case the previous example went a bit over your head, this is what you should be looking at to understand first, and then maybe go back to that example to understand it a bit more. So from dependency injector, we import containers and providers again. We have this class database with a few functions in them. We have this database container with the database name and a singleton provider, which creates the dependency object of this database class with the DB name as the database name. So if the name is name, that's in the main function. Container is a database container with the database name as my database, right? So this comes in, we get the configuration from here, my database. This goes into this as well. Database equal to container.database. So database is this singleton provider of the database class with the DB name as my database. Database.connect set self.connected for this database is true. Result, database.execute query select star from my table, which will return this string query select star from my table executed on database, my database. And database disconnect will set this self.connected as false again. So in this example, we define a simple database class that represents a database connection. We then define a database container class that inherits from the containers declarative container base class, which allows us to declare our dependencies and their life cycles. In the database container class, we declare a database name configuration provider, which allows us to set the name of the database we want to connect to. We then declare a database provider, which creates a singleton instance of the database class using the database name configuration value as its DB name argument. In the main section, we create an instance of the database container class, passing in the database name configuration value as my database. We then call the database method of the container to create an instance of the database class with the DB name argument set to my database. We connect to the database using the connect method, execute a query using the execute query method, and print the result. Finally, we disconnect from the database using the disconnect method. This example demonstrates how we can use a container in the dependency injector library to manage the lifecycle of a database connection, and how we can use configuration providers to easily configure our dependencies. The container ensures that we only create one instance of the database class, and we can easily change the name of the database we want to connect to by modifying the database name configuration value. So this is where dependency injector design pattern providers are making our life easier. Conclusion: managing dependencies can be a complex task in large software systems. The dependency injection pattern is one way to address this complexity by decoupling the creation of dependencies from objects that use them. This makes it easier to manage and test dependencies. Like here, whenever you create one instance of the database class, if you want to use it in a different database name, all you have to do is change the database name. So in that case, testing becomes a lot easier and can also improve the modularity and maintainability of software systems. Using a library like Dependency Injector can definitely make this task a lot easier in Python and improve code quality. So there's a bunch of more articles that I have on area of work in domain-driven design patterns, which we can discuss in the next few videos. So if you like this video, please subscribe, please like, and in case you want to keep getting to know about more stuff, design patterns, Python, frameworks, feel free to hit the bell icon. Great, thanks and happy coding.